Okay. All right, here we go, ladies and gentlemen. Let's go ahead and learn some synthetic division. Here. Oh, I guess I got to hit the play. All right. There we go. All right. So in this example, ladies and gentlemen, what they're doing is we're given x plus 2 is a factor of f of x equals x cubed minus x squared minus 10x minus 8, find all the zeros. So to do it, we got to understand a couple things. We know something is a factor. It's not isn't a factor, right? It's not saying ask is it. We know it's a factor. So since we know it's a factor, then what do we now know about this problem? What's one thing we now know? Yes. We know that the remainder is 0, right? So if we do synthetic division, and we can do any kind of division here, but if we do synthetic division and we get a remainder other than 0, we know either the problem's wrong or we did something wrong, right? So let's go ahead and check with synthetic division first. So here's my factor, because we said it's a factor. I want to use my 0. So I'm going to do -2. I'm going to take my coefficients, 1, -1, -10, and -8. Now following synthetic division, bring the first one down as 1. 1 times -2 is -2. -1 plus -2 is -3. -3 times -2 is a -6. -10. -10 plus -6 is a -16, and looks like we have something that is wrong with that, right? What? Oh, it's just regular 6. There we go. Yeah. Sweet. So therefore we have -4. Thank you very much. -4 times -2 is now positive. We have our remainder 0. Good, right? You guys caught me for making like my mistake, but that's important because we knew if I didn't get a remainder here, I would have to go back and check my work, right? Or I have to work over there with the problems. So again, remember this is my remainder, this is my constant, this is my linear term, and this is my quadratic. That means the quotient is x squared minus 3x minus 4. But again, guys, it's saying find all of the zeros. So what we have to do is remember, what does doing division tell us? Like, if 4 divides into 12, 4 is a factor, right? But if 4 divides into 12 3 times, that means 3 is a factor. So if x plus 2 is a factor of this, that means how many times it goes into it, which is this, is also a factor. And just like we did over there, if you're given a factor to find the zeros, all you have to do is set the factor equal to 0, right? Now the problem with this graph is this is not linear. So what I'll have to do is set this equal to 0. X squared minus 3x minus 4. Well, you look at this and say, okay, we have to solve it. It's a trinomial. Oh, factor, right? We want to look for factoring. And fortunately for us, this is factorable. What two numbers multiply give you -4, add give you -3. Now I have this written as linear factors. I already know that one of my zeros is -2, so I can just write my zeros are 4, -1, and -2. Right? Okay. So that's why this is how this can be helpful. And this is how you're more likely going to be applied with a synthetic division problem. However, guys, remember it's synthetic. It's not always the best. Don't put it on a pedestal. Okay? Because all I have to do is give you guys a problem that looks like this. So, what if I change the problem to a factor of x minus the square root of 5, and I give you a new polynomial? Go ahead and give yourself 5 to 10 seconds to go ahead and set up synthetic division and then think about what you would do. Okay? Okay, so up, what you guys can see is this is not always going to be the synthetic division is something you guys can definitely do. However, I would say it's not something that is preferred. But you can definitely do it, guys. Put the square root of 5 here, set up the coefficients. The only problem is, what you're going to have to do is do operations, you know, with radicals. Which is something you guys learn in algebra. All you're doing is add, subtracting, and multiplying, right? It's not really the end of the world. But I would say it's a little too much work for this, okay? So what I'm going to do is take this approach a little bit differently. What I want you guys to look at is, let's use our understanding of factors from the warm-up, right? When we did our warm-up today, we did all linear factors except for the last one, the second last one. We had x squared minus 5. And what that was supposed to teach us is that if we have positive square root of 5, if we have positive square root of 5 is 0, then we also have to have negative square root of 5. The conjugates apply. So what that tells me is if I have x minus square root of 5 as a factor,
you'll have x plus square root.
I have to have x plus the square root of 5. Right? You can't introduce the square root and not do plus or minus. That's a game changer, because now what I can do is I can multiply these out, and that's going to give me another factor. It's not going to give me the linear factor. It's going to take me back to an x squared minus 5 as a factor. But now I can use division with that. I can't do synthetic division anymore because it's not a linear factor. But I can do long division. And in my opinion, that's a lot easier than doing synthetic division with radical operations. Right? So when I multiply these out, just applying the FOIL here, or difference of two squares, I get x squared minus 5. And that is my new factor that is in quadratic form. So now I can take that and I can use long division. X to the 4th minus 3x cubed minus 6x squared plus 15x minus 5. Again, this is why I was saying for you guys to be really comfortable with our long division. X squared divides into x to the 4th. X squared times x squared is x to the 4th. X squared times negative 5 is a negative 5x squared. Right? You want to make sure you put them under like terms. You can use place values if you want. Number one mistake students make is they subtract incorrectly, so make sure you put parentheses. And you subtract vertically, that goes to 0. Negative 3x. Negative 3x minus 0x is just a negative 3x cubed. Negative 6x squared minus a negative is going to be negative x squared, or negative x squared. That would just apply everything all over again. X squared divides into a negative 3x cubed, negative 3x times. Then multiply the negative 3x times both terms. Negative 3x times x squared is a negative 3x cubed. Negative 3x times 5 is a negative 15. I'm sorry, positive negative 15. I want to bring down this positive 15x. Okay? And then we can put 0x squared. So parentheses and subtract. That then goes to 0. Negative x squared minus 0 is negative x squared. 15x minus 15x is, again, 0. X squared goes into negative x squared. How many times? What?
Yeah, drop down to 5 too, right?
Yep. So I did negative 3x times 15, so
yeah, so it'd be negative 1.
Right, so x squared divides into negative x squared.
Negative 1 times.
Negative 1 times x squared is?
Negative x squared.
Negative x squared.
And then
Negative 1 times negative 5 is?
negative 5 and top down. You change your equation to be a positive at the end.
Yeah, just I think maybe that should have been positive 5. I made a mistake. Okay, that was positive 5. So therefore, where did I lose you?
Nowhere.
No, she said she was confused.
We're going to you go way too fast.
Okay, well, let's go through this. I mean, the part of the reason why I'm going a little bit faster is, guys, we did this last class period, right? I gave you homework on it. So I'll slow down though, but just tell me in the rows that you guys aren't following.
Yep.
First term, you always divide into the first power. X squared divides into x to the 4th, x squared times. If that doesn't make sense to you, rewrite it like this. X squared divides into x to the 4th, how many times? X squared times. So now, once you have that, you take that term and multiply it times both terms of your divisor. X squared times x squared is x to the 4th. X squared times negative 5 is negative 5x squared. Again, it's really important to put parentheses and subtract, and I'll say this out loud. X squared minus x squared is 0. Negative 3x minus, there's a cube there. You can put a 0, there's nothing there, you can put a 0. Negative x cubed minus 0x cubed is just negative 3x cubed. That's a lot of times we just bring it down. Negative 6x squared minus a negative 5x squared. Double negative is basically the same thing as adding. That's where I got the negative x squared. And then these, I can just bring them down. You can bring down both of them if you want to, but I only like to bring them down as needed. Now, for that first round, does anybody have any questions on where I came from and where I got this? No? Okay. So then, you just go to this, you go into the next quotient, you just apply the operation all over again. X squared goes into negative 3x cubed, negative 3x times. So that's my quotient. Then I multiply that times both of these terms. Negative 3x times x squared is negative 3x cubed. Negative 3x times negative 5 is going to be a positive 15x. I don't have anything for x squared, so I just write 0x squared. I put parentheses around, and I subtract. Subtract rows vertically, that goes to 0. This minus something is just negative x squared. This 15x minus 15x is 0. So my only term of my quotient is the negative x squared, that's really flat. X squared divides into negative x squared, negative 1 times. Negative 1 times x squared is negative x squared. Negative 1 times negative 1 is positive 5. You can see there's this number over here. I could have kept on bringing it down if I wanted to, but I only want to bring it down when I need it, which is at the very, very end, because now when I subtract, I should write it here. Because negative 1 times negative 1 is positive 5. So now when I subtract these, I get 0 and 0. Which we knew, right? We knew that this should have been a remainder. That's why we caught, I was looking at my problem and said, oh, I multiplied that wrong when I was creating this answer. So what the issue is, guys, we know this is a factor. We know these two are factors. Now that this divides into this evenly, we found another factor. So we can set our factor equal to 0. But there's an issue with this one. This one doesn't what? Can't factor it, right? So therefore, John, what we need to do is if we can't factor something, we can either complete the square or we can apply the quadratic formula. So, again, guys, I want you to remind you of this. It's not going to be implied that, oh, you have to solve quadratic formula, right? You have to look at the problem. Every problem is going to be different. The first problem is easily factorable, right? Some problems, you're going to have to decide, oh, crap, this is not factorable. I need to apply a different method. You have a question?
I'm so confused about how you know x plus squared minus
X plus squared minus factor? So just go to, like, you agree with, like, if x squared minus 5 is a factor, you set it equal to 0, add 5, x squared equals 5, square root, x equals plus or minus the square root of 5.
But how do you know x squared minus 5 is a factor?
No, this, I told you, it says given, that's a factor.
Yes.
So what I'm saying is, if you have negative square root of 5, you have to have positive square root of 5.
But how do you know x squared is not
Oh, well, because I divided it and I got a remainder of 0.
Where did you get that
Supposed
from?
to be.
That's the product. This times this is this. Think about it like this. 2 is a factor of 12. 3 is a factor of 12. 2 times 3 is 6. 6 is a factor of 12. Right? Work. And that's the same thing I'm doing here. Just multiplying two factors, I'm getting a third factor. That factor gives me another factor. Like, so that's all I'm really kind of doing.
How did you get from x minus the square root of 5 to x squared minus 5?
How to get from where?
How did you get from given that as a factor? How did you get x squared minus 5?
I just multiply this.
But where did you get the
You
x?
have to have the. There's always a plus and minus before a square root.
If you're given the minus, you have to include the plus.
Okay.
Again, it goes back to this. When you solve, you have plus or minus. Always.
Okay.
Always.
It's like when you're married, you have your husband, you can't really.
Alright, so for time purposes though, I want to at least finish this one, guys.
Yeah.
Alright? Because I do want to give a imaginary solution one that we got to kind of go over quickly. But again, if we're going to solve this, alright, we need to use the quadratic formula. So x is equal to opposite of b, so that's positive 3, plus or minus the square root of b squared minus 4 times a times c all over 3 times a. Right? Not always, but most of my examples, that's been the case. So now we have x equals 3 plus or minus, let's do some of this work in our head. Negative 3 squared is 9. Negative 4 times negative 1 is going to be a positive 4. So it's really 9 plus 4, which is 13. All over 2. Now what we can do,
like separate.
yep. So typically when we write these out as zeros, we want to have this separated. So we write it like 3 halves. Can you please stop talking about it? I really appreciate it. 2. So if we want to write the zeros, like we want to find what are all of the zeros that are here, right? So Cassie, what I would do next is I would just write the zeros down here, and I'd say the zeros are, you guys can use plus or minus, that's fine. The zeros are, we know, negative square root of 5 and positive square root of 5, right? So I could say plus or minus the square root of 5, comma, 3 halves, plus or minus the square root of 13 over 2. Well, yeah, so let's think about that. You always want to go back and check your work, right? We have 4 zeros. Now, we have 4 irrational zeros, right? Nothing's like nice like an integer. But we have 1, 2, plus or minus, 3, 4, plus or minus. That means by the fundamental theorem of algebra, we should also have a degree of 4, right? Yes, we found all the zeros of the polynomial. It took a little extra work because of quadratic formula, but yeah, it's the process. Sometimes it's going to come out easy, sometimes it can be a little work.
So back to the square root thing, so anytime they give you a factor that has a square root, you can assume that it's plus or minus.
You don't assume, yes, always.
Okay.
Because that's the only way we get square root of 5 is by taking the square root, so it has to be plus or minus.
Okay.
Right? And that's the same thing with imaginary, which I'm going to do right now. But I'm going to end this stream so I can just talk to you guys normally. Bye-bye.